Hi everyone, my name is Steve. I'm an Alibaba Cloud Technical Trainer. Today, I'm going to share with you a topic I believe you will be very interested in, which is understanding the database technology that powers Double 11. Here is the agenda for today. Firstly, we will have a quick introduction of Alibaba Cloud Shopping Festival achievement on year 2018. To better understand the technical challenges behind this worldwide biggest online shopping event. Then we will take a look at the current database market to understand the current database technical evolving trends. The third part is an overview of Alibaba Cloud database products portfolio. And the last part of this course will introduce the most commonly used Alibaba Cloud data products in Double 11 and their major usage scenarios with technical details. Now let's look into the first part, why database matters to Double 11 Shopping Festival. For anyone who is not familiar with Double 11, please allow me to give you a very quick introduction. In China, there are two biggest online shopping platforms. One is called Taobao.com and another is Tmall.com. Taobao.com is a C2C mode business platform and Tmall.com is B2C mode. They both belong to Alibaba Group. Starting from year 2009, we initiated one market event on November 11 for selling goods with very good discount in just one day. It turned out this is a very successful marketing event and customers like it. So we hold this shopping festival year by year. Now you are looking at the numbers of last year's Double 11 shopping festival. I highlighted the two metrics with color red. These two metrics reflect how fast now we can process the incoming orders and payment in Double 11 promotion day, especially during the peak hours. When I say peak hour, I mean at the middle night of November 11, the first second of the workload grows 122 times. It's like people at the seashore looking at the calm sea with a mild wave. Suddenly, the wave becomes 100 meters high, which brings the ultimate challenge to our system. Demand extreme elasticity, extreme performance, and even under such tsunami, we need to ensure transparency to end users. That is, the response time felt by customers shouldn't change too much. So from this chart, the blue line, you can see before and after the peak hour, which is the first hour of Double 11 day, the response time didn't change too much. It was kept less than 1 millisecond. Pretty amazing, right? In previous page, we mentioned about a measurement called order per second. This is a measurement from customer point of view. But actually from business logic perspective, we can imagine transaction per second could be up to 100 times of the value of order per second. And even more, query per second could be up to 10 times of value of transaction per second. Because query per second, sometimes we call them a QPS, usually means how many single SQL statement is served in just 1 second. Based on these numbers, you can easily tell how powerful and elastic our backend infrastructure, especially database service, could be, which is also the reason we can make $30.8 billion GMV in just one day. So let's have a quick summary here. The challenges from Double 11 come from three aspects. The first one is your infrastructure need to be extreme elastic. The second one is storage need to handle different access pattern in an efficient way. And the third one is since $21 million per second are being processed, we cannot afford any single point of failure. That's why Oracle and Oracle RAC may not be the solution to us. Before year 2009, most of our key infrastructure was built with servers from IBM, database from Oracle, and storage from EMC. These systems are very good at handling steady incoming requests, but not good at scaling out when incoming requests grows 10 or 100 tabs in just minutes. That is why after our first Double 11 event, we decided to work on one thing, to remove IOE from our backend infrastructure. Since then, we entered the era of open source database starting from 2009. Through distributed database middleware, TDDL, open source database, AliCircle, it is our Alibaba Cloud MyCircle branch. Also including high-performance x86 servers and SSDs. Through the joint efforts of DBA and our developers, we successfully replaced the commercial database Oracle, IBM, Compact, and EMC high-end storage finally in year 2013. Removing IOE brings three major implications. The first is to solve the scalability problem, so that the database has the ability to scale out. This laid a very good foundation for many years in the Double 11-day trading peak. The second is self-control. We add a lot of features in AliCircle, such as inventory hot patch, Circle current limiting protection, thread pool, and so on. Many features are derived from the Double 11 for technical requirements of the databases, which is completely impossible in the era of commercial databases use. The third is stability. The original in the era of commercial database, just like putting all the eggs in a basket. Removing IOE not only solved the single machine failure, but also through the multi-active structure, we can upgrade to make the database out of the city's limits. Now we can achieve the database cross-city, active mode, and disaster tolerant. The availability of the system is greatly improved. In year 2016, we started a homemade database development, codenamed XDB, now called PaulaDB and PaulaDB-X for distributed version. You may ask why you want to do some homemade database. There are several reasons actually. First, we need a native distributed database that can be deployed globally, similar to Google's Banner. The second is that the Double 11 scenario puts a very high demand on the database. On the one hand, performance is highly required. On the other hand, the storage cost. The database uses SSD to store data, and the data has obvious hot and cold characteristics. A large amount of cold historical data and hot online data were put together. Over time, it's taking up a lot of valuable storage space, and the pressure on storage cost is increasing. So after carefully evaluation, we found that improvements based on open source databases were no longer sufficient to meet business requirements. The third reason is the emergence of new hardware technology. If the large-scale use of SSD and x86 server performance greatly improve the process of removing IOE, then the NVM, the non-volatile memory, the FPGA, the heterogeneous computing, including the RDMA, the high-speed network, and other technologies will be the second push for the transformation of database technology.